everyone. Welcome to the IEEE Communication Society podcast series. This is episode number 10, and we are fortunate enough to have various colleagues and experts from different fields working on 6G and beyond. And we will be discussing about the emerging 6G technologies and their work, and how we can learn over the sort of technology roadmap that has been going on, that has been decided, and there is a general consensus over the period of time. So let me introduce you with my colleagues here on the panel. So I have Professor Periklis Hazimisios, if I said it right.
Correct.
He's a professor at the International Hellenic University in Greece. And I should also mention that the panelists we have today are from one6G as well. So 16G is a consortium of many industry and academic members, and they work on different technologies. I mean, some to name a few is Messi MIMO and non-terrestrial networks, integrated sensing and communications on cloud-native AI applications, and so on. Several of these aspects they work on. So he is one of the working Group 1 vice chair there in one6G. And then we have Professor Luca De Nordis. So he's an associate professor at Sapienza University of Rome in Italy, and he is leading the working Group 2 vice chair. He's a vice chair of Working Group 2 in 16G, the same consortium that I just mentioned. And then I have my colleague Joseph Eichinger. He is the head of 6G research and prototyping in Huawei in Germany. And we are really lucky to have you guys here. And I need to mention that you're also the Working Group 4 chair.
Yes.
So it's hard to remember every introduction, but here we are. So we will be discussing about these 6G technologies and so on. So to start with, so we have as you're aware, IMT 2030 framework, the 6G framework from the ITUR. So people have agreed, the community has agreed on several of these technologies which will go into making 6G a reality, right? So we have a hexagonal framework. So in 5G, unlike 5G, we had like a triangular framework where we had the enhanced mobile broadband, ultra-reliable low-latency communication, and also machine type communication included there. So we expand on those technologies, right? We have immersive communication, and we have, keeping the same high reliability and low latency communication and so on. And we add some new enhanced capabilities. So basically in terms of integration of sensing and communications, then you have integration of AI and communications, and also ubiquitous connectivity is a part of it, right? Especially in terms of non-terrestrial networks and so on. So we will circle around our conversation, about these topics, and then we will see where we go with our discussions. So maybe Periklis, I can start with you. So basically we mentioned these technologies there are, right? So we think of many use cases around these, right? So let's say in case of, vehicular communication, in case of, we are coming with these, virtual reality sets, we have this immersive communication, we have holographic sort of solutions, and many other technologies that we talk about. So Periklis, would you like to touch on what you have been working in your 16G group, and also your areas of interest and research areas that you would like to share with our audience watching this podcast?
Many thanks, Arian. It's a pleasure to have the opportunity to show also the work that has been done in 16G network. So myself and my colleagues will elaborate on this in many aspects. And now about use cases in Working Group 1, what we're investigating is all the use cases, no matter if they are from 5G or they are towards the 6G, because many people are still wondering what is the real difference between 5 and 6G, and the first thing that they will check is the use cases. What 6G, what new use cases the 6G will bring. Mm-hmm. So we have certain use cases that we investigate and we study through the several work items that either belong to Working Group 1 or they are with collaboration with other working groups like Working Group 2. Some of them I can name are the 6G empowered robotics, which is very new. The one that I was chairing for 1 year and a half, which has to do with multimodal and teleoperation and related topics. But also there are some others that also touch items like sustainability, etc. So talking about use cases, I can name a few use cases that we think that make sense for 6G. First of all, it's the empowered robotics that have to do with certain applications and that touch from public safety, like the use of robots or UAVs in an autonomous way in order to help in disaster scenarios. The other application that sits under the 6G robotics is anything that can be used like cooperative robots in healthcare, in agriculture, and many other areas. Still thinking of how robotic communications can help. Another area that of use cases that make sense is smart communities and smart cities. Please have in mind that this is not a new area. We've been discussing this in previous generations as well.
Yeah.
So not very new. However, talking to if we talk about what 6G is expected to bring in these use cases, especially in smart communities, is about community engagement and governance in a way that 6G will be needed and can support this kind of applications. And another area of use cases that is very, very important and very interesting is public safety. In many countries around the world, we have seen that the last 5 to 10 years, we have a lot of natural disasters, plus the fact that there are some man-made disasters that happen, and 6G is expected to support some of the new applications that will be related to public safety. I can name a few: the situation awareness, and also the use of, as I also already mentioned, robots for search and rescue, for
so like mission critical.
Yes, mission
services.
critical, the prevention or the recovery, the response when a disaster happens.
Yeah.
So 6G is expected to provide the connectivity and to meet the requirements of these use cases. And of course there are some other ones like immersive communication oriented, vehicular communications, that also it's not a brand new number of use cases, but on the other hand, we're expecting to probably realize autonomous driving.
Yes.
That it didn't happen yet.
Yes.
Right?
No, this is a very good point that you raised about the autonomous driving as well. I mean, besides many other things that you said. So basically, when you talk about integrating sensing and communication, so it has very good application in this environmental monitoring that this automated vehicle has to do, right? Mm-hmm. So I think these are very nice points. So Luca, would you like to add about your working group in 1/6G and also what kind of research activities you have been involved in?
Yes, thank you very much, Aryan. Thank you for the invitation. So yes, as you mentioned before, I'm the vice chair of working group 2 in 1/6G, and the goal of working group 2 is to explore the foundation technologies that will end up in 6G, which is a broad set of technologies. Some of them are not properly technologies, they are techniques, they are algorithms. So I think that 1/6G is trying to keep it as open as possible. And you were mentioning, for example, somehow the integration of sensing and communication. That's definitely one of the areas where we are investigating now. Just to give a very brief context, the activity in this working group is organized by work items. So we have currently more than 10 work items that focus on specific technology, specific aspects, and one work item is on integrated sensing and communication. And I think that's going to be a very important aspect in 6G. More in general, the spatial information, which is something that we already start to see in 5G. So if you look at the evolution of 5G, more recent releases, they start to support explicitly positioning, active positioning in that case, which wasn't there in 4G. Yeah, there was support, of course, but not to the point where you could hope to replace, for example, GNSS in many cases. And here the idea is to have a seamless support for positioning, which can come from active positioning, but can come from sensing. So the integration of radar, so passive positioning, active positioning, and communications is something that we don't see yet. We see trends towards it, and hopefully this is something that is going to be part of 6G. And then, of course, it's something that is not vertical, is horizontal across most of the use cases that we discussed, because, of course, accurate position information, the capability of detect users, devices, obstacles is something that can be leveraged in almost all the use cases that we mentioned so far. So I'm personally working more on active positioning, but I think that all of these topics will eventually merge. So there will be multiple solutions to different problems, and there will be a mix of different things: communications, active positioning, passive positioning, that is sensing.
That's interesting. Yeah. Joseph, would you like to add something on these about your working group activities and your development, prototype development sort of activities?
Let's say in the setup here, we see clearly we have a group that is working in 1.6G on the use cases and to justify somehow what is the benefit of technologies for the later business, because the business needs use cases and technologies are just to support commercial benefits later on. And working group 2 is doing the exercise to develop new solutions. And I'm in working group 4 on my team, or maybe all of the members of 1.6G. We are really happy to try to find out what is, let's say, in reality, what can be done in reality based on the use cases, what we take from the working group 1, and the solutions, what we reuse from working group 2.
Right.
And it's for sure we have a broad, let's say, setup of use cases right now, and a broad, and I'm really happy to say this, setup of demos, what we also have shown at this year's 1.6G Summit. As we started some years ago, we have started with 4 demonstrations. Now this year we have 20 demos.
Wow.
Yes, that means it's really exciting to see the engagement of all of the members. And it covers robotic. I'm really happy about robotic because I see this as a very new use case. But if you talk about robotic, we should really make clear that we are not talking about robotic in factories anymore. So that is 5G. And 5G has discussed this along and intensively. And now we are convinced that robotic goes out from factories. Maybe in future we'll have a buddy at home that helps you, or your elderly guys, your parents maybe, and this guy can maybe walk, whatever. And this is what we think about. And this needs additional capabilities like sensing. And AI. And if I look to the demos, what we have at this days now, tomorrow and next day, it covers all of these aspects, from sensing, positioning sensing, distinguishing between robots and humans, because for a collaboration issue, you need to know what is there a human maybe close to you, or AI, neural network receivers. We have, as Huawei, also contributions on robotic here, because we want to show that robotic and AI and the usage of large language model can bring all of this into a new level, what was not possible in 5G at all.
So am I right in saying that 6G will be just beyond connectivity, beyond just communications?
Sure.
Because you mentioned about all these added capabilities and so on. So you're not just connecting people or connecting things. It's maybe things to things, or even beyond that. I mean, beyond communications specifically.
Yes. So sensing, as already mentioned, and also some other aspects that probably will later on refer to. That were not present in 5G, like legal and ethical aspects. That everyone is discussing this. It's a really new topic for many of us. Since being an engineer, usually you don't consider this kind of aspects. But on the other hand, the massive collection of data by sensors, by devices, by networks, etc., is creating some issues, is raising issues that need to be discussed. No idea, I think, for most of us what is going to happen about after this discussion, because discussion means that we probably conclude that something needs to be changed, that we'll also we need to go back to the technologies and change things or add
Yeah, that's right. There are these societal
certain mechanisms that will,
Yes.
for example, provide privacy or will anonymize the data, etc. So
Yeah, this is very right, actually. So we have these societal concerns, right, with privacy and security and the ecosystem that is secure enough. I mean, some people talk about these small private networks. But in the case of, let's say, large stadium or something, when you have to provide connectivity or taking the connectivity from your non-terrestrial entities like, satellites or something, so they have, they're covering different regions. So there is a problem that, how secure enough is the data, right? In case of sensing, communication, positioning, perhaps, localization as well. So you cannot sense each and everything that you want, right?
Yes.
There has to be some bounds to this.
Yes, I think that the real issue is to find the correct compromise. Because on one hand, you want to make communications, and I mean, broadly speaking, communication meaning sensing, positioning, the services related to communication, as seamless, as transparent as possible, because it gives you a better user experience. Right now, we are still in the process where you have a mobile phone that has multiple wireless technologies, and many times you still have to pick which technology do you want to use to do something. This is something that changed because it's smoother now than it was before, but it's still there. I mean, if you have multiple access points, you have sometimes manually select the access point you want to connect to, which is something that should be automated right now. On the other hand, if you don't have any control on what is being used, which data are being used, which technology is being used, you also lose visibility if somebody is using this data or collecting this data without you knowing it. So it's a very thin line, and I don't think anybody has an answer yet. Of course, there are those that say, okay, let's go with technology, and there are some other people that say, okay, but privacy is also very important. So I think we will have to find a compromise. What is the compromise? I think it's an open question right now.
Exactly. I mean, with all the technologies that we think, non-terrestrial network-based technology, integrated sensing and communication, integrating AI with communication, they have the security and privacy are one of the key concerns. Am I right in saying that for these technologies? And we also see that there are many other challenges involved, right, in these technologies. I mean, how to handle such a large amount of data when you are trying to integrate, different functionalities together, and how to really make it cost efficient and also having less complexities in already complex models that we are dealing with, right? Like for a satellite with heavy payload, and you're throwing in some new advanced architectures and so on, some, and also you're trying to cover different mega constellations of these, NTNs and so on, that LEOs connecting with GEOs with MEOs and so on, different aspects to provide connectivity to the ground user, to the ground network that we have. So already we have complex systems with adding AI and other things, sensing as well. So do you think that we can, overcome these challenges? First of all, I would like to ask what kind of different challenges that you guys can mention and how we can overcome these. Any ideas on these?
Well, I can mention that there are some challenges that are, again, horizontal to all the technologies that you want to use. So, for example, recently we opened in WG2 a work item on sustainability, which is not specific to any technology. It should be a broad goal, which might mean, okay, in this context, I want to use this technology and not this other technology because it's more energy efficient, it has lower impact under any point of view. So the point is also to find the right metrics to measure the sustainability. How sustainable is a system? Does it cost more but consumes less? It has a smaller CO2 footprint. So it's really an open challenge, and it's something that I think will be more and more important, because one thing that you will see more and more is integration across technologies. So you will not be able, okay, you can optimize a single technology, but how do you do the optimization when you have maybe 10 technologies to select from? Which is the optimal combination?
Exactly.
And of course, AI and data science can help in that, but I think it's a big challenge. It's an interesting one.
Joseph?
Maybe I have two comments here. We talked about privacy, we talked about data security and whatever. And I guess and sensing is maybe a bit complicated thing here, because if we apply sensing, if we take radio waves as a kind, it's a reflected signal, what we get from the radio wave, and we analyze this more deeply. At the moment, for communication, we just throw away what we get as a reflection. But in the meaning of sensing, we take this data and we try to analyze, okay, this reflection comes from my table or from my TV, and so it's a wall. Okay, it comes also maybe from a human. And now the question is, what happens with the data what I get? With cameras, I have for sure a privacy issue because I can identify you. With radio sensing, it's difficult to identify you. That means it's from the principle here, maybe a bit of privacy, a private technology. I can see it as a human, but it's not Mr. XYZ.
Sure.
And the next point is we have to think about where are the data computed and which data do we expose to somebody else. If we expose a dot cloud of you,
it's very important.
Nobody can identify you. It's not possible at all. If we expose maybe more private data, then the privacy issue starts. If we apply AI to analyze the data, your movement pattern, maybe then we have to see where can we encapsulate the data in order to keep it in a private shelf. And this is what 6G must answer.
Very important point he raised. Yes, that's true. So thanks, Joseph. I think you made a good point. So maybe please, I can point out another sort of aspect for this, continuing with our discussion, is that how do you think that we have these interesting technologies on board, right? We are, on paper we have this very new sort of approaches, designs, visions, and so on. But how real are these? I mean, how pragmatic or practical these solutions are in reality, in our day-to-day lives, in our everyday lives. So when do we actually expect 6G to be in our phones, on our equipments that we are using? What do you think?
Yes, you know that I'm getting this question for when I'm lecturing in the university as well.
Right.
My students are after the lecture or during the lecture are asking, okay, but how about 5G? So you keep discussing 6G, but how about the current generation of communications?
You see, some countries also don't have 5G yet. So
yes,
we are already
yes.
discussing 6G and beyond.
So it seems that for many countries, 5G is offering faster connectivity in the mobile devices and nothing more. And I'm talking about the general public and not necessarily some implementations that will be in factories or in other areas that will provide 5G connectivity and will solve problems that we couldn't solve by using 4G. But how about the general public? I'm not sure if now we still have we now have 5G implementations enough for the general public to be happy about that. I would expect that for 6G, you ask for the time frame, the official time frame, that it's 2030. On the other hand, as we have seen, there are many research works published already talking about how to extend or how to modify or how we have invented or developed new technologies that will touch the next generation, the 6G generation of communications. But I'm really curious to see about implementation. You said about, Joseph, about the demos, and I'm also very happy. So it seems that we are doing much better than last year. But I don't know if we're expecting to see more real implementations in 6G comparing to 5G. I don't know if you can comment about this.
Maybe we have to make clear that if 6G is coming in 2030, as you said, it's a standard freeze. It's not the product.
But standards have to be frozen earlier,
but
if you want to
2030 is standard. It doesn't mean that you have the next day a product in your pocket. It means it could take maybe more time, maybe 1-2 years until you get the first 6G product. And then we have to look that 5G will not end at 2030. It will still continue. It's the same as we have recently also LTE networks. It's not the case that we stop 5G and we start with 6G, because this will be very bad for the vertical industry, because they're starting now to invest in 5G, and they would be ensure that they can continue with this in the next 10 years and use it next 10 years. That is exactly now the challenge, to find something in 6G what gives an additional benefit after 2030. And as we know from 5G, we have started with release 15, but release 15 was a first attempt to do it, and release 16 with better features, but still not all features has been implemented in products. And that will also run here. And that means we should not communicate to the people, to the public, saying somehow and giving the impression that 5G will end 2030. That's not true. It will continue. And in some countries, as you said, maybe 5G will be the power horse for the next additional decade.
I agree with what Joseph just said. I just want to add that I think that the problem is really, as Ian is already said, to find a good case for 6G to justify an adoption. I'm sure that there will be some areas where the companies, the industry in that area will tell you, okay, 5G for us is not enough. We need 6G for this reason. And you have to show them, okay, yes, we can do that with 6G. It maybe will not be the general public immediately, because, I mean, if I have to say as a user in my mobile phone, yes, I have 5G. Do I need 5G? Probably not for many things that I do, because 4G works very well. Under mobility, it's probably still more efficient than 5G because deployment is still ongoing for 5G. So there will be multiple technologies coexisting. As Joseph was saying, 5G will not go away. 4G is not going away anytime soon, because, I mean, there are companies that invested on machine-type communication using narrowband IoT, and narrowband IoT is still there. So why should it shut down? If it fulfills the needs for an industry, there is no need to change. So I agree that there will be both a technical evolution, but also somehow a commercial evolution, meaning that you have to find what companies really need in order to push a new technology. And I'm sure that there are areas where this is needed, because 5G did not fulfill anything that was needed. But we will have to be good to find these areas, and also to drive the technology to fulfill those requirements.
Yeah, so you need to do some sort of discoveries on what you really require and what you really can, manage to do with 6G services, right? So going on to that, I mean, just continuing with the points. So I'm also interested to know that are these technologies that we are talking about, are these just immediate ones that we require just in next couple of years, or we can see them even beyond 6G? I mean, we can see them in 7G or even beyond 7G, let's say.
It's a far away horizon.
I know it's far away,
but it's 10 years after 6G,
yeah,
for sure.
It's never easy to predict, but what do you think, that are these technologies sustainable? Will we keep them for a longer period of time, or this is something that we just involve into our 6G infrastructure, and then later we have to come up with a new technology? What do you guys think about that? I mean, what are the future prospects of going beyond 6G, let's say, with these technologies we have in hand?
I think that we already mentioned that I can see 3 generations in the same time, right? Yes. Probably even 4G will not go when 6G will be deployed, because as Luca mentioned, some of the use cases will work without the need of investing more money and time to change the infrastructure and go to 5 or 6G. But some of the use cases, for sure, they will need 5G like now, or 6G in the future. So we're talking about not replacing all the networks. I remember this many years ago when I was still a young assistant professor, asking in one conference, so now it's going to be a new network, and everything will go away? And the immediate response was no. We're talking about coexistence of different technologies. Luca mentioned a lot of that there will be a lot of technologies. We have already in our phones 4 or 5 different technologies that reach from a few centimeters to many kilometers. And one of the main challenges is how we can combine all these technologies in a way that the end user will not have to choose or to know the characteristics of or the benefits and the advantages of its technology. This is why I'm referring to general public, because many times we forget we are doing research, we are studying use cases, but we forget that most of the people, no matter if we are going to master these technologies, they need to at least understand the basics. And I really believe that what is missing from our world of engineering and of research and implementation is a bit of training or a bit of let's say knowledge going to the general public. I still remember what was happening when antennas in Greece and many other countries were deployed, and many people were against this. Even during the COVID area, there was some fake news of people saying that antennas will spread the COVID. We're not talking about hundreds or thousands of people. We're talking about probably hundreds of thousands of people believing that there is conspiracy, the conspiracy about antennas. We still are not convinced a lot of people about health issues and communications. So we need to probably spend some time and energy there as well, and not only in pure research topics.
Sort of like non-technical challenges as well.
Yes.
There are in addition.
This is
to
why I mentioned also legal and ethical issues, that some people are really sensitive about these issues, and they will raise concerns about this as well, I believe.
Sure. Joseph?
But that's a good statement, because in one6G we are always interested to find partners raising up these new work items, topics. If we have this problem now, or maybe this possible challenge, it would be great if maybe we can get members, more members, new members working on this and interested on this and applying for membership in one6G, and they can start this work item, and that would be really a benefit.
Sure.
As to us to look also to this aspect, not just pure technology ones. I also would like to compliment a bit your use case families, because what we also did together is working on digital twins. Because that is also what came up during 5G time, actually, at the beginning. How can we build a copy of the reality in a virtual world, not just for entertainment and for gaming, but also for serious, let's say, call it serious gaming, to simulate factories, to simulate environments, even cities, smart cities. And here, we have started this digital twin work item, I don't know, some months ago.
Yes.
It's a joint work item between working group 1 and 4, because the aim is to build a platform where all members can jointly work on it.
So are you doing any experimentations and prototypes around these? Would you like to mention some? As
I said, the idea is to define what means digital twin for 6G. It's not just a robot or a factory. What is it's mechatronic. It should also include radio and sensing, for sure, because sensing is the main aspect what we need to cover. And but the digital twin should help us to predict some behaviors, maybe channel behaviors if you talk about communication, and to maybe solve channel challenges as a radio propagation challenges with higher frequencies. Because 6G is also about higher frequencies. In any generation, we get an additional frequency band, hopefully. I hope so. And in 6G, we talk also about sub-terahertz. It means we are talking about hundreds of gigahertz. That's a completely new field, what was never discussed.
But sub-terahertz is more like a complementary spectrum, isn't it?
Yes, it is.
It's not to be used in every geographical location.
For sure not.
We are focusing more on centimeter wave, low to mid-band spectrum.
Yes, that is for some maybe outdoor, broad, let's say massive deployment.
Yeah.
But we have still this in our research as a work item on sub-terahertz.
On sub-terahertz as well. Luca?
Yes, just to add some thought about, you said, how sustainable will be these new technologies. I mean, it really falls into implementation also, because, of course, if you want to keep it sustainable, it should be something that you also can update and evolve in time. But I think that, I mean, the industry has been going on in that direction for a while now, because, I mean, we hear more and more about software-defined radio, software-defined networks, meaning that we are pushing the boundary between hardware and software implementation more and more toward the antenna. So, of course, when you switch to a new technology, there will be some pieces that you will maybe have to change, because the antenna might be different if I work to a different frequency, but most of the hardware will be something that you can repurpose to do something new. I mean, we already have right now base stations that cover multiple generations with the same hardware, because you have everything done in software, and then you have the conversion to the analog domain closer to the antenna, and that will be a big push in order to help innovation, because you will have more flexibility. So you could say, okay, look, I want to change this protocol, I want to change this waveform, and this is not something that will require to go there and change the hardware, so change the network. It will require an update, a software update in the end. So I think that really helps in not having to worry too much about, okay, I do something now talking about standard that is frozen for 10 years. I mean, it's not frozen. Of course, it's frozen for that release, but if then you want to change something, in many cases you will be able to do it without additional hardware modifications. Part of it you will be able to do it in software.
Yeah, I think it sounds great. So I think we discussed very, very interesting points. I mean, going forward with beyond 5G and 6G and even beyond these technologies. And Pericles, you also mentioned very nice, interesting use cases, and Joseph, more practical sort of ways to do these, and Luca as well with about different new technologies that we can come across. So I think it was a very nice discussion we have had, and thank you so much for making time and coming here and sharing your thoughts, guys. And hopefully we can do such a podcast again some other time and discuss about some new things and new updates and maybe 1/6G's sort of activities, some new maybe working groups that you guys will add maybe in future.
So we are thinking about this already.
We can discuss about this. So thank you so much for coming, and see you next time.
Yes.
Thank you very much.